Microplankton, diverse collection of organisms found in the water that are unable to propel themselves against the current. Bioluminescence is used in different ways by the phytoplankton on Vekia. A. As a defense mechanism to draw predators towards the creature trying to eat the plankton. B. In disorientating and surprising grazers with tiny flash of light. C. To warn off the predators that the plankton is bitter or poisonous. Easier to recognize a second time. And D. To attract commensal zooplankton that will eat dead and decaying phytoplankton. Macroplankton. These phytoplankton are visible to the naked eye, at least the bigger ones. They are still very tiny. A teaspoon of Vekia saltwater could contain a few hundred. Zooplankton. The organisms that form the zooplankton are diverse. They are generally translucent and larger than the phytoplankton. Some of them feed on phytoplankton, some are predatory, and some are even scavengers. The scavengers feed on what we call the necroplankton, dead and the floating remnants of organisms. Through their consumption and processing of phytoplankton and other food sources, zooplankton play a role in aquatic food webs as they become food themselves for bigger animals. Marrowplankton. Marrowplankton consist of larval or juvenile stages of larger organisms. They vary in size from a few microns to a few centimeters. The marrowplankton begin life drifting throughout the sea until they grow and mature enough to settle in another area. Some of them may become sessile while others thrive in the pelagic zone all their life. The Quadrivalve start their cycle of life as a soft tiny larva. Even though muscle contractions provide propulsion, slow swimming movements cause the marrowplankton to get carried away by the currents. Their forearms are covered with gluey hair that help them catch passing phytoplankton or decaying organic matter. Pissioplankton are the superpredators of the planktonian microcosm. They have a pair of fins as well as very long whiskers that allow them to detect the movement of other plankton. The thorny growths that cover their bodies do not protect them from bigger predators but rather from themselves because they are cannibals. The clade species of Pissioplankton are capable of producing weak bioluminescent signals. Rather than chasing their prey, Pissioplants prefer to attract them by means of light signals reminiscent of the light emitted by luminoplankton. The Pissioplankton is an ambush hunter. The corona Pissioplankton cannot emit light, however, their slender bodies allow them to move without too much difficulty between the various debris and plant microorganisms. Their crown helps them blend into the drifting algae. Bulliphysia are a clade of ancient, rootless algae that spread like carpets on the seabed. Very often it happens that the gas giant Vek completely blocks the light of Vec Sol for days. To counter the prolonged absence of direct Vec Sol light, these small filamentous algae have developed a strategy of storing nutrients and sugars in bubbles. This evolutionary adaptation has proven to be a winning survival strategy trait and has also been passed on to the other clades of marine plants. Physioplankton is an ancient sea plant clade. The species that make up this clade are very common. The tubes of these algae are filled with a sweet oil that is lighter than water. As a result, their tubes allow them to maintain a certain buoyancy so they can capture light while remaining attached to the substrate by their holdfast. Gangliophysia is a clade of algae that is close on the evolutionary tree to the clade of Physioplankton. They are smaller and more compact. Chrysophysia is an algae type of organism related to the Physioplankton family. To capture more sunlight, this type of algae is made of ribbon-like structures. It is such a delight to see them undulate with the movement of the sea. The color of the algae is pure yellow, reminiscent of gold, hence the name. In some areas, they form a grassy meadow on which many life forms thrive. Luminophysia is a type of kelp from the Physioplankton family. This clade is close to the Chrysophysia, and together, they form the Nastrophysia, or ribbon algae family. Luminophysia forms sparse forests and provides a unique habitat to many marine species. It can reach a maximum size of 50 meters and its ribbon-shaped thallus can be up to 10 meters long. The center of Physioplankton's stem is hollow and filled with sweet oil. The stem is an appendage of the fistula and is actually considered an extra part, or an extension of it. The most interesting feature, however, is the presence of 3 luminous bulbs at the top of the fistula, which attract different benevolent organisms. Syrenophyceae are algae of the Vesicular family. Vesicular have a more elaborate vascular system than Fistulophyceae. Their vesicles are perched on a stem in which the vascular system is located. Although the nutrients are stored solely in the vesicles, this system allows them to move to all parts of the plant. The Syrenophyceae are named for the melodious sound made by the ocean currents rubbing on their leaves. This friction produces different notes depending on the size of the leaf. The vesicle and the leaves of Syrenophyceae also emit faint light. Saphirophyceae are small algae no taller than a blade of grass. Members of this clade are part of the Vesicular family. This clade has 2 unique features, their proto-limbs and the opaline deep blue hue of their vesicle. Although colored, this vesicle is semi-translucent. Saphirophyceae are not very energy hungry and they grow very slowly, therefore, they tolerate lower light and are able to survive in greater depths than other algae. They also taste rather bitter. The Caerulophyceae clade is made of small, pure blue telescopic seaweed. These algae grow in dense beds, the largest species do not exceed 50 centimeters. The beds of Caerulophyceae are important for sediment deposition and substrate stabilization, and they are important breeding grounds for many species. Members of this clade have interconnected sticky roots rather than holdfast. They can retract when they feel threatened. The Lanceophyceae clade is made up of large algae whose vesicles are perched on telescopic stems that can measure up to 3 meters high. These algae proliferate mostly in the tropics, but there are representatives of the clade in all of Vekia's oceans. The stem of these algae retracts every night, but also when the ocean current is too strong or when they feel threatened. On the other hand, during the day, when everything is calm, it stretches out above the other algae in order to catch the most sunlight. Moreover, the single vesicle is protected by an organ that looks like a big green petal. The inner part of this organ is not luminous but rather iridescent. The Quadrivalve family forms one of the major evolutionary branches of the Vekia moon. Morphologically, they are formed of 4 muscular valves that surround a blind gut type of stomach. The oldest clades of Quadrivalve, including Quadrivalve and Quadrivalve, are sessile and filter-feeding marine mollusks whose body is surrounded by a shell made up of 4 articulated parts. The inner part of their shells is made of iridescent mother of pearl. The Penistramidea are a clade in the Quadrivalve family. They stand out the 4 colored feathers which swing with the currents and which serve as their digestive organ. When they feel threatened, Penistramidea have the ability to lock themselves in their shell. They leave it when the danger is no longer felt. Their life begins with a larval stage before coming to settle permanently on the seabed. The juvenile, shell-less, is very exposed to dangers and predators. Their great number is their strength, and only the most tenacious, or the luckiest, will succeed in forming a protective shell that will allow them to reach the adult stage. Gastropelagidea are members of the Quadrivalve family. They are ambush predators that prefer to hunt at dawn and dusk. They produce a soft, pulsating, and hypnotizing blue light that is appealing to many life forms. To increase their chances of a catch, they've developed a pair of tiny rudimentary eyes. Their main muscle is so big and that the adults can no longer protect themselves inside their shell, hence the other features that allow them to defend themselves against predators. The first is their very long stings filled with a neurotoxin that keeps other creatures from getting too close to their base. The second, which exists to defend their upper part, is their ability to violently move their arms in every direction. A very scary sight. Quadripedea is a clade related to Quadrivalve which, in the course of its evolution, internalized its shell and became mobile. The juveniles are light enough to move around like jellyfish, but once adult they are so heavy that they prefer to stay on the seafloor. Their textured skin allows them to go unnoticed when foraging among the seaweed for the small critters they feed on. They are solitary animals capable of defending their hunting territories with verve. They also have sticky limbs. The Carcinosidea are tiny creatures akin to crabs, in their appearance as well as in their behavior. However, instead of having an external shell, these critters have a shell beneath a thin layer of skin. In fact, during their evolution, the species of this clade gained rigidity in certain parts of their body, in particular in the limbs and the four parts which form the body. The rigid limbs allow them to move by walking on the seabed. Carcinosidea are mostly detritivores but will hunt smaller vermin for nutrient supplements. They are very shy and are mostly active at night. The Dolichocephalusidea are filter feeders of the Quadrivalve family. Their flat bodies are zebra-striped with exuberant patterns. Their hind limbs have evolved into a pair of fins that undulate, camouflaging as strands of algae cradled by the waves. Their forelimbs serve as a filter for capturing plankton. When they've captured enough and a limb is filled with plankton, the creature moves it into its mouth to extract the food. Dolichocephalusidea prefer to stay in small groups to forage in the algal canopy. However, when they have to move into open spaces, they make sure to stay well protected from potential predators by hiding underneath larger, non-threatening animals. Vermidea. This family is composed of purple-fleshed vermiform creatures called Vermicidea. These first clades are made up of small crawling creatures that feed on decaying organic matter. The Archovermicidea are one of the oldest clades. Many species eat them as they are at the bottom of the food chain. They are often tiny and have a color that matches the ocean floor. They usually move under the sand, in small galleries, and feed on the decaying matter of Photophagus. Dolichovermicidea have evolved into a longer body. They use the 4 sensors that grow on their head to pick up the scents of decaying creatures. They especially like rotting meat. They are not the most colorful animals as they usually have a color that matches the bottom of the sea, just like Archovermicidea. Their flat tail allows them to swim very short distances when they feel threatened. Poplavermicidea are thick worms that feed on decaying plants or animals. When they travel, a large female leads a small harem of 4 to 6 males, leading the predators to believe this linear arrangement is a larger creature. The female mates with the males that have followed her the longest. They can emit light to scare off persistent predators. Cassideidae are a clade of filter feeders. Their mouth is divided into 2 parts, an intake and an outtake. They have a shell strangely similar to that of the first Quadrivalve. Thanks to this disguise, they are less likely to be eaten, even if their shell is less hard and less efficient. Their large body always remains hidden in the sand under their tripart shell. The Pampinocidea clade includes small planktonivorous worms that usually live wrapped around the stem of Luminificea, the algae with which they live in symbiosis. The members of the clade normally take on the shade of color of their host to better conceal themselves, and 2 small legs with white suckers allow them to cling securely to their slippery stem. They have a long, sticky and transparent tongue that collects the zooplankton that are attracted by the luminous globes of the Luminificea. The Pissidea is one of the most prolific clades of the moon. One of their major features is the 2 pairs of eyes, which allows species of this great family to adapt to the different light regimes that the moon undergoes because of the 2 large bodies in the sky. The first pair of eyes is adapted to the clear and vivid light rays of Vesicular. The second pair of eyes is an adaptation that allows better sight at night than in the dim light emanating from reflection on the hazy gas planet Vek. Archopiscidea is a very ancient clade of vertebrate. The members of this clade move gently, in a shy way and in a small and loose shoal. They can quickly find cover anywhere when they sense danger. It is actually hard to get close to them. The Phasmopiscidea clade is made of 2 fin fish. They are shy and elusive little creatures who take up residence between the fistulas of Fistulophyceae. To reward the Phasmopiscidea for ridding it of the various worms and phytophagous organisms that attack it, the alga secretes a thick sweet honey that the fish crave. Each Fistulophyceae is home to a small number of these fish. During the mating season, the fish perform an elaborate dance, and only the most beautiful male and female from each patch of Fistulophyceae earn the right to reproduce. Proeectopicidea is a creature related to the Pissidea family. The representatives of this clade are found in compact schools. They move together without hierarchy and they feed mainly on zooplankton. They are ultra-fast fish with 6 fins that hum like the wings of hummingbirds. Their fins emit a very weak bluish light. This allows them to identify easily their congeners and to remain grouped between members of the same species. They are very energetic and do not hold still. The Nemrudidea clade is made up of species of predatory Pissidea with 6 fins. Members of this clade are distinguished by a band of faint light that crosses their body but also by their fleshy fins. The pair of short barbels on their lower jaw allows them to detect vibrations emitted by their favorite prey, the Planktonic. They generally move in small bands of a few individuals. They are formidable small predatory creatures, hence their name. The Microplankton clade includes species that show slight sexual dimorphism. Males and females have minor distinct characteristics. Females are all black and dull, while males have a very pronounced coloration on the edges of their fins and are able to emit light with luminous organs located on the head and the snout. The snout's organ emits beautiful elaborated pulsating light. They are creatures that live in small groups and that feed on small invertebrates. Their long snout allows them to dislodge their prey in small crevasses and other tight spots. Latipusidea are bottom-dwelling fish that feed on small invertebrates, mainly carcinose crabs. They are usually black or dark brown with silvery white spots on their back, and the oldest individuals can reach up to 1.2 meters. They have whiskers that have both tactile and sensory properties. The Latipusidea clade is special because the interior of their mouth emits a pale blue light that inevitably draws in prey. Latipusidea are meat-sized creatures that feed exclusively on plankton. At maturity, the males can reach a size ranging from 2.5 to 3 meters while the females, larger, can reach up to 5 meters. They have filtering apparatus they use to scoop out plankton, which is similar to baleen plates. The latter are of a whitish color, and this is why the Latipusidea look like they are smiling when they feed. They usually do so on the top of the water column, because that is where the density of plankton is the most significant. It is not uncommon to see the fins of this creature as they move nonchalantly. The fins actually looks like little sailboats cruising between the ocean's waves. Latipusidea are carnivorous fish-like creatures, and they are very much on top of the food chain. These predators are mostly active at night. They have long fins that help them maneuver through the water, while their crescent-shaped tail provides bursts of speed. They are of medium size, about the size of a seal, and have powerful jaws with sharp teeth. What makes them particularly dangerous, however, is the fact that they are very intelligent and tactically capable when hunting in packs. Small protrusions at the bottom of their lower jaw enable them to detect the electrical impulses of other creatures. The Latipusidea clade stands out because the species from this family have a distinct juvenile and adult stage. Coming out of microscopic eggs drifting in the ocean, the younglings start their life underwater and feed on all they can catch because they are carnivorous. However, when food is scarce, they can become scavengers. They move in small schools. The distinctive markings on their head allows adults from the same species to recognize that they are kin, and thus the adults are not interested in eating them. They are not cannibals, the adults are benevolent towards their own. The fish phase lasts 2 or 3 seasons, and the juveniles are numerous because few reach adulthood. A chrysalis phase allows the internal organs to reorganize, the small translucent fins fall off, the gills turn into lungs, the wings are formed and lengthen, and the body as a whole becomes fit for flight. The Latipusidea younglings form their chrysalises on the intertidal zone, near the adult colonies. The adults protect the chrysalises from potential predators and watch over the nursery. The adult phase is a relief for these creatures because they become safe from most marine predators. They can live up to 40 Vekia years. They feed on marine prey which they capture by diving head first like boobies. They are very comfortable in the air and in the water, but extremely clumsy on the ground. They have no legs, but rather 2 protuberances at wing level which allow them to cling on rocks and cliffs when they need to rest.